I want to open this thing up. You guys, you can, I mean, jump in. We've got, let me see. I had a hand that went up and then it disappeared.
Ross, hi, me.
Go for it.
Hi. This might be completely off the wall, but I'm looking at the thing, the way it's working and it's bouncing around there, and the way the spring is moving. I don't know if it would benefit things if you actually got some more stability into the way that's actually operating. So you're maybe losing some efficiency and energy the way it's bouncing around. And one of the ideas that immediately struck me, I play guitar professionally, outside of doing various other things. Have you seen something called a whammy bar on a guitar? So if you turn the guitar over, and it's the bar a guitarist would use to make the, that's operated by a spring tensioning system. And there are all sorts of designs of these that control the movement and efficiency of the sound and the way the strings move, but do it in such a way that you get a tremendous result. Now, something like that, potentially, it just struck me looking at the way the strings, the springs moving, might be adaptable to your machine to actually give it a bit more whack and a bit more control. It's just an idea. I don't know.
Yeah, currently these are this is a 100-pound garage door spring. So
yeah,
when it's getting pulled, that's 100 pounds of force.
Yeah.
So if you think about, down there, the bottom of the machine is feeling 100-pound pull up temporarily. I mean, only temporarily while it's decelerating, and then while it's accelerating. But I could swap these out for shorter springs, or I can get more garage door springs that are weaker or stronger. And I mean, I was gonna have a piece of plywood here to prevent this from because it was going back here and almost getting stuck. See back here, and that's dangerous. And just before I got on, I was moving this with my hand, and see this loop. It's a little bit of slack. It has a little bit of slack, so that it only engages when it finally gets all the way up here at that x-axis. So for this point, it's slack. See the slack? There's all this slack. And the crazy thing is, this loop accidentally looped around this piece. And, it stopped the whole thing instantly. So if that had happened while I was on the video, this whole machine would have just gone through the wall. So I cut this piece shorter so that this couldn't wrap itself around. But I mean, I literally just cobbled this together, the last pieces of this just now.
It may be worth checking out the commercial guitar makers like Fender and people like that. If you go online and have a look at the way that their systems operate, the sort of tensions that you actually use on a guitar to actually control that, it's not too dissimilar to the figures you've given me. It's about 80 pounds typically on a string, and you've got 6 of them. So you've either got 3 little short springs like that operate using a plate, and it moves in a controlled way up and down. That could actually, I think, maybe increase the efficiency of what you're doing there. And actually maybe, give you a better performance.
Another thing I want to point out, and back in my bedroom, down the hallway, I have another machine just like this.
Right.
Wasn't as good. I was trying to make it lighter weight so it could maybe float. So I was drilling holes in it, making it as light as possible. It got to the point where it's dangerous. It's going to just break itself apart.
Yeah.
But that's back in my bedroom. But basically that has not just a slider down here, it has another slider up here. So this beam is sliding along 2 tracks of bearings on the other one. But this one, I got such expensive, strong bearings. I only needed 1 set of tracks right here. But I found a company that does air pneumatics, like with like air pistons. And I contacted them. They told me that they could set up a sensor, to the flywheel, and they could actually program it in a computer to where this arm would go back and forth by pneumatics. So it wouldn't take away any of the energy from the gyroscope, because right now the gyroscope has to also spin this back and forth, and so their machine would have 2 air pneumatic pistons that would be like pss, 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 computer controlled, so it would stay in perfect distance. So this whole machine would have air pistons pushing it back and forth. That right there would, increase the efficiency of this by a lot, right there off the bat. So that's another thing I'm looking into. But again, I don't really, this thing now, I mean, we can make much better stuff than this.
So Ross, let me jump in real quick. I want to ask before we go to Harold, do you have a website? Do you have bio information or anything like that? Because part of it is I got to put this stuff up on the website, man. I want to break this out into a separate session.
I've never published anything ever.
You got can you put some and I can pick this up after the, like Facebook, anything like that, just so people can get in touch with you. And
but even on my Facebook or Instagram or nothing. I've never said anything about any of this at all. Like only my, like Bryan and like my mom and my brothers and my girlfriend, they're the only people that know that I have ever done anything like this. So
yeah.
And I've just never published anything about any of this at all.
Well, let me go to Harold, and then Brennan actually had a question in chat also. So, but let me go to Harold first. He's got his hand up. Harold, sir.
Yes.
Oh, Harold, my fault. I hit mute. Sorry. Can you?
He's still muted.
Yeah,
okay.
There we go. I'm sorry.
Yeah,
I was trying to
okay.
lower his hand.
That's okay. Ross, good job. Look, you're pushing the boundary. That's good. My question for you is, I noticed you have the big wheel and you're calling it gyroscope. Now you remember what it reminded me, we all seen in high school where the teacher put a student on a chair that can rotate and put a bicycle wheel, turn the wheel, and then the student start in precession, going around and around. Now, your big wheel should produce a similar gyroscopic force due to gravity since it's vertical. And you have too little weight on the periphery of the big wheel. How is the sum of all the forces, the natural gyroscopic force of the big wheel versus those two ways? How do you synchronize it? And what would be, the advantage of doing it that way, the sum of all the forces? What would it look like? Have you done that experiment to estimate the force of the big wheel with the smaller weight on the periphery?
First off, I don't think you could create linear thrust from just gyroscopes, because normal gyroscopes are spinning at just one constant speed, 200 RPM, 300 RPM, whatever. So I feel like that can't never create thrust, never. You have, like I said, you have to accelerate it for 90 degrees, decelerate it for 90 degrees, accelerate it for 90 degrees, decelerate it for 90 degrees, accelerate it for 90 degrees, decelerate it for 90 degrees, accelerate it for 90 degrees, decelerate. So unless you can figure out how to get a gyroscope to speed up and slow down and speed up 4 times per rotation. If it's just going in one speed, it's nothing. It's just spinning. It's something spinning. And yes, there is a pole in between, like a gyroscope. When a gyroscope is up in speed and spinning, there's what's called the center of gravity. So like if I took all these springs off of here and I just spun this up full speed, This thing will go up to thousands of RPMs, like really, really fast. And right here in the center, there's like a pole, an imaginary magic pole in the universe. Like it's this magic pole forever. And so the gyroscope is like balanced on this pole in the middle of the universe. So, you know, and then if you tilt it, it precesses. You know, if you tilt the gyroscope, there's a pole, an imaginary pole. So it wants to stay on that pole. So if you tilt it, you know, it precesses. But all that is a twisting. It's right. It's still at that center. You're never gaining anything. You're never gaining any type of linearity. You can't create thrust from that. No matter how much you try to, you know, however you try to pivot it, you know, make, you know, precession, you can't do anything with precession. It's all right. It's all stays right there in the center. It's a turning force. It's just a twist. It's all just a twisting force. So nothing, you can't go anywhere with that, with gyroscopes. So it's, you know, that's my opinion of it. I mean, maybe I'm wrong, but I feel like I've been doing this for a long time. I've done a lot of stuff, and I've never been able to do anything with gyroscopes ever. I've thought that they could. I've tried to swim, like, you know, make them swim. I've had 2 gyroscopes, and fast and then slow, fast, slow, fast, slow, fast. It doesn't work. It's, you know, it goes fast, and then I go back and forth, and nothing happens with 2 gyroscopes. You know, even with precession, nothing happens. Nothing works. That's my opinion of it. So I don't know. I don't play with gyroscopes anymore. I mean, this looks like a gyroscope. I guess it is, but it's never going to spin at one constant RPM. It has to change speed 4 times per rotation, which is insane. It's completely crazy, but that's what you've got to do. It has to be like a wave in nature. Deceleration, acceleration, deceleration, acceleration, deceleration, acceleration, deceleration, acceleration, deceleration, acceleration. It has to do like nature does. That's how nature works. So you have to figure out how to do it that way. Gyroscopes themselves just spinning at 1 RPM is not, you know, that's not like a wave. I mean, do you understand?
Thank you for the explanation. And good luck. Keep on doing your work. I hope you succeed in the end. You're doing a lot of good effort. Thank you.
I've seen your stuff too. I think you're doing a good job as well. I don't know if yours is going to work. I've never really examined it, but good on you too, because you're out there trying yourself.
Well, thank you.
You're welcome.
Okay, and Harold, thank you, sir. Thank you. And let me see, we've got more people popping into the conference here. So who, again, Alt-Y on Windows or Option-Y on Mac? Anybody, if you have questions, we've got about 20 minutes left before Michael McDonnough comes on. I would love to have questions for Ross. And Ross, you've been on, you've presented several times, so.
Yeah, I saw someone say in the chat right now, an inventor from UK, Sandy Kidd, had some success with gyroscopes. I actually remember I talked to Sandy Kidd on here.
You did, yeah, when Sandy was on.
And remember how I brought up this whole thing to him? I brought up the whole idea of springs and accelerating, decelerating at 90-degree angles, and he actually agreed with me. He was like, once you do it that way, once you figure out that you have to accelerate and decelerate it, and the spring is kind of like a capacitor, I mean, the real energy is coming from the motors, obviously, but you have to have some type of like spring mechanism to kind of like store up and then release energy, store up and release energy. But it's always happening in a straight line. The energy is always flowing up. You know, it's just energy is just moving straight up.
Well, so Brennan had a question. Actually, I should go to this one. And Brennan, do you want to ask this? If you still, yeah. Here, let me ask Brennan to unmute. And can you turn on your camera also, Vernon? If he's paying attention. What Brennan was asking was, how do you isolate the resistance so that the thrust is directional and doesn't cancel itself out? You've got it turned into linear motion, but it's still reciprocating.
Well, I mean, right now, yeah, I mean, it's so heavy. It's not, I mean, I think it's creating some thrust up, but obviously I don't have it on scales right now to prove that. Like Bryan St. Clair is putting his stuff on a catheter totter, a balance beam. So when he turns his machine on, it actually, you know, it goes up, and he turns it off and it goes back down, and then he turns it on and it goes up, and then he turns it off and it goes back down. So one second.
I'm sorry. Can you hear me?
Yeah.
Okay, I was able to step outside where
Oh,
I'm allowed
okay.
to use my mic. I can't
Brennan,
use
thank you,
video
sir.
here. I guess, and maybe this isn't a complete model of what you're trying to work with. What I'm wondering is, you're absolutely getting some deceleration on the upswing from the spring and everything like that. However, once it crosses the top dead center, basically, the spring is going to accelerate it back down. So I'm wondering how that's canceled out, or is it that only has one spring and maybe the full model has more or something like that?
Well, think about that. So you just admitted that the spring, you know, for this half is decelerating the gyroscope, right?
Correct.
So think about that. If I were to reach up with my arm, my muscles, and try to slow down a gyroscope, right? I'm going to get lifted off the ground, right? Right?
Yes.
So think about conversely. So that's deceleration. So think about if a gyroscope was going real slow and I reached up and I accelerated it. You see what I mean? When you accelerate it, it's a time. You're changing time.
Is this with weights at all or no weights?
Well, I mean, the whole thing is a big, heavy gyroscope. So if you grab that point and I accelerate it, I also pull myself up. You see what I mean? So you're
I mean, the way that I'm seeing it right now is that so you've got the reciprocating portion that is completely opposite of what appears to be a weight. I may be wrong. Is that a correct assessment?
Yeah, well, that's just a counterweight I put on there to kind of balance things out. Pay no mind to that.
Oh, okay, I got you. So, in other words, the ring that would be rotating should be the same weight all the way around. Is that what you're getting at?
In theory, yeah. Like in Bryan St. Clair's machine, it's a perfect gyroscope.
Okay, gotcha. Okay, that's all I was wondering. Because, like, if, for instance, the way I was thinking, if that was a weight on the other side, then yes, you'd be accelerating the wheel, but you'd be accelerating the heavy side downwards, which would counteract itself. So that's why I thought that.
Yeah, but the whole idea is like during deceleration, like you're expending energy to slow it down. You're like, slow down. And so when you're slowing it down, you're getting pulled up with it. You're like, oh. And then conversely, now that you've slowed it down, you're like, fuck it, I want it to go faster again. So then you pull it back. And your same concept, you're using muscle, your energy, a spring, some type of energy. You ate food, you have energy in your muscles, and then you can accelerate it down and make it faster. And when you're doing that, you're pulling energy in one direction, and you also get pulled up. So that's basically the whole idea. But I forgot to mention this. I actually have a video of this. I didn't get prepared, but basically what's happening is you're messing with just those 2 points on the gyroscope, and there's an imaginary center in between them called the center of gravity. And so when you decelerate this one point, the center of gravity, what happens is this point that you're decelerating travels a slightly longer trajectory up, and it pulls the other point in a smaller trajectory. Like, you know how the ballerina, like she's spinning around like really slow, and then she brings her arms in, and then she starts spinning around really fast in a tight spin, and then she puts her arms out again and she spins really slow. It's that kind of concept that you're trading off a long trajectory for a short trajectory, and the center of gravity moves, and we call it mass displacement. So the center of gravity, this imaginary point in the universe, mysteriously moves in a perfectly straight line, and now they're reset at that point. And then when you accelerate it, the same thing. Now you're creating a longer trajectory. You're creating a shorter trajectory. You're creating a shorter radius. And then this one down here is going to create a slightly longer radius to catch up. And then, so now you've again reset the center of gravity. So each time the center of gravity is jumping, is moving through space. So the whole center of gravity is moving through space. So basically you're taking advantage of 2 points on the gyroscope to like expend energy, accelerate, decelerate it at 90-degree angles to create a wave pattern to basically, change, and it goes up and up and up like that. And I've graphed it. It looks like a perfect wave, not a perfect wave, but it's a wave pattern. So they're trading off shorter trajectories for longer trajectories. So they're called arcs. A shorter arc for a longer arc. A shorter arc for a longer arc. A shorter arc for a longer arc. So it's constantly doing that and moving itself up through space. That's basically what's happening with the 2 different points on the gyroscope. And you don't need a full gyroscope. Like I said, you only need 2 points. So I could get rid of the gyroscope altogether and then just have a flat, like a rod, and then have 2 weights on each side. That's it. You don't need to have the full gyroscope. You could just have a solid rod right down the middle with 2 heavy weights on the ends, and that's all it is. That's a gyroscope. Any gyroscope is just at least 2 points spinning around each other. You don't have to have a full gyroscope. I just did for the hell of it. But you could just do it with just 2 points.
There we go. Okay, so let me see. So who? Mark has his question. Mark has his hand up. Mark, go for it, sir.
Hey, Ross. So we've actually been playing with gyroscopes over here at the lab, and you've seen this contraption before?
Yeah, I saw you doing that. I saw the guy coding last week. The guy's coding it. He's coding.
So what variation of this experiment have you tried? Was it an actual device, or were you just holding them in your hand?
Well, like that particular one?
Yeah, you said you were doing something with a swimming motion with gyroscopes. Was it a mechanical device that you're talking about, or was it just 2 gyroscopes in your hand that you were swinging them back and forth?
Yeah, I was just swinging them. I mean, but I've done so many different types of things. Like, I had a couple hanging from strings. I tried to torque them one way and then torque them the other, and thinking, I get where you're going at with that. So I think what you're trying to do is you're spinning 2 gyroscopes, and then you're going to try to swim in space, right?
Yeah, I was thinking of doing adding a 3rd motion to it as well. Mike Gamble mentioned you got to go slow in one direction and faster in the other, which is similar to what you're talking about as well. There has to be a change in speed of the gyro's axes. We're talking about this axis over here, but with the servos. But if we were able to do an actual swimming motion, which is like you move forward with the gyro in this plane, turn it, and then move back like that. That might make even a better, inertial propulsion device. Although designing that is tricky, but
yeah, what you just said, that might work. What you said just now, how you would have to change it at a 90-degree angle.
that's literally how a swimmer
Yeah.
moves his hands
I
too.
think that might actually work. I'm not sure, but that sounds like it could work. Potentially, it would be totally different from this. But yeah, it would be really hard to do that. But yeah, I don't think you could do it like the current way you're trying right there. I think all you're gonna do is, like, no matter how slow you try to change it, you're going to go backwards. Like you try to go back.
Another way to do it would be to move the gyros forward in this position and then have them come out like that.
I still don't agree with that kind of stuff. I still am on the impression that that's like the hula hoop idea that you're trying to trick. You know what I mean? Like you're trying to come at this as like a logical idea.
The thing about a gyroscope is it only creates torque when you're moving it in a direction other than its plane or axes. So you can move it freely along its plane. So when you're going outward, there's no resistance to that. But when you're bringing it back and it's not with the plane or the axes, because it's actually turning its direction, that's when you're going to create a forward thrust.
Actually, that's a good, wow. Okay. Yeah, that's a good point. Yeah. Because if you take advantage of the pole, that it's on, like I said, the imaginary pole.
Guys, I'll be right back.
Is going in a circle and it's got a pole. You might be able to, that, because at that point you're taking advantage of the fact that it's on a pole, like I don't know, some type of universal pole. It's on a pole, and if you could somehow then, I guess, change that pole and then try to create thrust, maybe, and then reset it. I don't know, maybe. But that sounds like you're kind of getting on to somewhere there. That sounds pretty interesting, actually.
That would be interesting to see how to build something like that. It would probably have to be like a rail system to get it to go in such a shape.
I don't know.
Well, so what you're saying with the using the pole instead of the gyro itself, so to speak, I actually think that's a pretty decent idea, and you could utilize the same method, or the same way of thinking about what you're doing with the gyro there on the pole, where you're speeding up. Like, let's say you cause it to go into a precession, and you speed up the precession one direction and then slow it down the other direction. So what you would end up with is kind of like potentially like a tumbling end over end thing eventually. But as long as you had a way, and you could do it with probably just with magnetism on each end of a rod that's going through the center of gravity, like you're saying. I don't know if that makes sense.
Yeah, I mean, I've never myself like fully got into the whole figuring out make thrust that way. I really feel like this is the really most efficient way, because it's like a lot of weight spinning around in a circle, and instead of like worrying about the center point, worrying about precession and all that, like you just take advantage of one point all the way out on the periphery, way out on the side, so that it's the most amount of travel. So that's where the most amount of momentum and force and the most amount of like that you can do to the gyroscope. You want to really focus way out here, like on the end, the periphery, the furthest out. That's how I feel is the most efficient way to get linear thrust. That's my opinion of it.
Do you have any plans to put this on a balance beam of some sort? See if there's any weight loss, or
I don't. I'm like in Washington D.C. around his area, so I'm like I don't really have room to do that. Like I said, I think the best thing I'm going to do is I made it so I could take this whole thing apart pretty quick, take the motors off, take the chains off, take the gears off.
If you want to bring it up here to New Jersey, we got a forklift, and we can we can figure out some sort of lever system with a counterweight. You know,
Yeah, I was thinking about coming up there that one time. You're like right near Manhattan, right?
yeah.
Like right across. Yeah. I was looking at me and Brian were both thinking about coming out there. Then Brian had something to do, and then I was like, okay, I guess I'm gonna go. Whatever. But we were him and me were both thinking about going up there that time. But yeah, I mean, I got this thing. I could take this apart, put it back together in like 30 minutes or something. I mean, everything's set with set screws. I can just undo everything and everything comes apart, and then I can put everything back together. Because there's no way I'd get this out the door right now. It's so big. But once I take it
Also,
all,
I noticed you're using pressure treated wood, which is about 3 times heavier than regular wood. So there's a big diet that we could put that machine on. Trim a couple, maybe even 50 pounds off of it.
yeah. I don't know. Me and him, Brian, and that's why we're even showing you this thing, because at a certain point, me and Brian were like, yeah, we're not going to patent this thing. This thing is so ridiculous. Like, let's just show the APEC to kind of at least let y'all know like what we're doing, kind of. But I don't know. I'm not really too worried about this thing here. This was just something I'm gonna. At some point, I want to get this out to a parking lot and then put it on its side on wheels and then see if it really gets a lot of thrust and then measurable thrust. And then I could be like, okay, I was right. This is the way.
How about you just put it on a boat?
I could do that too.
A raft.
I might do that too.
Great job.
All right, thanks, man. You too, man. You're doing some good stuff, man. That's pretty cool. You got your own little factory there, man. I don't know how you got a factory in Manhattan. That's crazy. That's awesome.
We're in Hawthorne, New Jersey.
Yeah, right. Yeah, but it's like I was looking on the map. I'm like, dude, y'all are like right. I mean, sure, you can look out the window and see all the buildings and stuff, right? I mean, there's a pretty cool view,
Yeah, you can see them.
Yeah, it's pretty awesome.
Yeah. Well, so we have just about 2 minutes left. Z has his hand up. Let's see if we can squeeze one more in. Z, go for it, sir.
Hello, can you hear me?
Yep.
Hey, Ross, it's Zach. How you doing?
Pretty good.
Yeah, and Zach, can you turn your camera on if that's okay?
I don't have a camera, but
Oh,
Zach
okay.
Mueller?
Yep,
Oh, hey man, what's up, dude?
nothing.
What? You finally got on.
Yep, I found an animation that we made a long time ago. If you want me to show that of your machine there.
Yeah, if you can do it super fast. Yeah, slap it on up, Zach.
Yeah.
How do I do it? Share
You just
screen?
hit the share screen. Yeah.
Is it working?
There. Yeah, actually, it's working perfect.
Cool. So you don't have that second spring on yet, but that kind of just shows the symmetry.
Yeah, but I do want to point out, remember, Zach, you are wrong here because you have the spring going all the way up.
Yeah, it's not exactly right.
It's not exactly right. It has to stop halfway.
Mm-hmm.
But yeah, that's pretty much what's kind of going on here.
Yeah. Yeah.
Yep. All right. Well, that's just all I wanted to show. So
Zach, thank you, sir. Thank you very much.
Yeah,
Okay.
Zach has been a real big help. He does all 3D stuff, animations, and wow, yeah, Zach, you're really good. He is a really smart guy.
yeah, we're working on some other stuff too. So maybe someday.
Okay. Well, yeah, and Zach, we would love to have you back on when you have stuff to showcase. So Ross, we're at the top of the hour now. We're going to go to Michael McDonnough. Let me see. I better bring up his info so that I can give him kind of an introduction. So let's do this though. I want to put this thing on gallery view. Everybody, please put your hands together for Ross Small. Ross, thank you for the demo, man. Thank you for explaining and walking us through the whole thing. That's amazing. It's amazing stuff, and you're doing amazing work too. And I think it complements what Brian is doing, and we've got a bunch of other folks doing stuff. So thank you. So let me